Number 16, we want to find the slant asymptote, the vertical asymptotes, if any, and graph F and all of its asymptotes on a graphing utility. Alright, so from this function, we will have a vertical asymptote. We set the denominator equal to 0. We'll get a vertical asymptote of x equals negative 5. You set it equal to 0. X cannot be equal to negative 5, otherwise you would divide by 0. When you look at the horizontal asymptote, you have to look at the degree of the top and the bottom. So we have a 2 and a 1. The top is exactly 1 more than the bottom, so in this case we will have a slant asymptote. And to figure out that slant asymptote, we can either do long division or synthetic division. I'll do it with long division this time. It's just easier to see the whole thing with long division. So we're going to have the x plus 5 on the outside. We're going to divide by x squared. Now we're missing the single x term, so I'm going to say plus 0x, just put it as a placeholder, and then minus 2. Alright, so with long division, we're focused on trying to make this x equal to this. What do I need to multiply by? X, so that it's equal to x squared, and that would just be 1x. And then you do x times x, and you get x squared. And then you do x times 5, and we get 5x. And then you subtract, or you change the sign, so this will become negative. This will become negative. These will cancel out, and then we'll get a negative 5x, and then we bring down the minus 2, and then we start over. What do I need to multiply this x by so that it's equal to a negative 5x? And that would just be minus 5. Okay, so at this point you have your linear function. That's our slant asymptote. If you want to keep going, you can. A negative 5x, and that'll give us a negative 25, and then you change the signs or subtract, but they change signs, that would always cancel out, and you'll have a remainder of a positive 23. But this is the part that we need for our slant asymptote. Our slant asymptote is y equals x minus 5. Vertical asymptote, only one. X equals negative 5. And then if you were to graph these, you would have a positive slope. Y-intercept would be at negative 5. Hard to see what's going on any of these. That one has a negative slope, so I will get rid of that one. This one has a positive slope, negative slope, positive. And if you look at the bottom, it says the window setting is negative 25 to 15, so this graph is shifted over, going all the way to negative 25 and only up to positive 15, and the y is going down from negative 50 to 60. We can graph it if we want it, but it looks like B is probably going to be our graph when we look at where the vertical asymptote is on the left side of the y-axis. But if you want to graph it, I can do alpha y equal, enter, make a fraction, and then we will do x squared minus 2, and then x plus 5, and then graphing it. This right now is on the standard graphing window 10 by 10, so we don't see this bottom part. But if I change the window to the fixture down here, we'll say a negative 25 up to a positive 15. If you want to, you can change what it's counting by. It looks like it's counting by fives, so I'll just say instead of count by ones, let's count by fives. And then on the y-axis, I'll do the same thing. We're going to go down to a negative 50 and up to a height of 60. And then we can count by fives as well, just so the spacing is a little bit better. And then we regraph it, and then you get a better image of the shape. So you still see these two pieces. The graph does not graph the asymptotes. Those are just imaginary lines that the graph doesn't cross. We usually just draw them in by hand as a dotted line.